This is Unit 1, Lesson 2 on solving linear equations. The objective for today, students will balance equations and use reverse order of operations in order to solve single variable linear equations. So to start, I ask first, what is an equation? And my answer to that is an equation is two or more mathematical expressions connected by an equal sign. And what we've been doing before in the first unit had nothing to do with equations. Those were expressions. The thing that makes an equation is the presence of an equal sign. So, that's an equation. Okay, 2 times 3 plus 1 equals 8. You'll notice that it's an equation even if there are no variables. This is an equation, 2x plus 7 equals 12. This is the kind of equation we're going to be solving today. It's a linear equation, but it is an equation. The presence of an equal sign makes it an equation. And here's another equation. The integral of natural log of x dx equals x natural log of x minus x plus c. That's a calculus equation, but even if you don't know what it is, you do know that it is an equation because of the presence of the equal sign. Now, what does an equation tell me? Why do we have equations? Now, what equations tell you is that the expression on both sides of the equal sign, the left side and the right side, have the same value. It's a given that these two things are equal to each other, so they are the same. But what does that mean? So what? What can I do with these equations? Well, since you know that they have to be equal to each other, you can use that to make a bunch of logical conclusions and take logical steps to keep the equation looking the same. So you can do anything you want as long as you do the same thing to both expressions. That way you can ensure that they both still have the same value, even if they might look different. That's the guy saying, why would I want to do that? Well, being able to change the way an equation looks, being able to move around the variables, move things from one side to the other, being able to change it looks without changing what the equation says, i.e. that they are the same value, both sides of the equation, both expressions. Now that's going to allow us to use logical steps to find the values for previously unknown variables. So what we're doing is we're working backwards from what we did last time. Last time I told you the value of the equation, and you found me the value for the expression. Now I'm going to give you the value for the expression, and you have to use that, logically work backwards to find the value for the variable. Sorry about that. Okay, I'm going to multiply 31 times 30, I get 930. Now I have 31 times x equals 930. So in order to unpack that multiplied by 31, I divide by 31, and I get x equals 30. Fractions are hard. You have to remember the least common denominator when you add, and when you multiply straight across. Numerator times numerator, denominator times denominator. We're going to spend a lot of time going over fraction problems because I know that it's a problem for a lot of people. Okay, now what if there's a variable on both sides? Well, this is actually easier to deal with than the fractions. So say I have one that says 7w plus 2 equals 3w plus 94. Well, if I just ignored the right-hand side and I looked at the 7w plus 2 and said, what would I do first there? Well, I would subtract the 2, so I'll do that first. So 7w plus 2 equals 3w plus 94. I subtract 2 from both sides, and the 2 comes off of the 94. So I have 7w equals 3w plus 92. Now again, I almost have the w isolated, but I need there to not be any w on the other side because I need to have w equals a number. I don't want to have w equals w plus something, or that's going to confuse me. That's not going to work. So I need to get rid of the 3w on the right-hand side. So I will subtract it away. So I subtract away 3w on the right-hand side. That means I also have to subtract away 3w on the left-hand side. 7w minus 3w is 4w, and what I'm left with is 92. So then in order to unpack the 4, I divide by 4, and I get that w equals 23, because 92 divided by 4 is 23. Now, say I have the variable stuck in parentheses. Well, we're going to need to learn a new trick called the distributive property. It's a new tool. Now, you can prove the distributive property, and I will. The distributive property works like this. If I have two numbers added together in a parentheses, numbers or variables, I shouldn't say numbers, terms, added together in the parentheses, multiplied by something else on the outside of the parentheses, then I can rearrange that and just make it the first number times the outside of the parentheses plus the second number times the outside of the parentheses. Now to prove that works, I'm going to plug in numbers for these letters and show you that you get the same thing both ways. So like I said, prove it. Well, if I have A is 2, B is 3, and C is 4, and I substitute those three variables in, it's going to look like this. 2 times 3 plus 4 in parentheses equals 2 times 3 plus 2 times 4. If you look at the left-hand side, 3 plus 4 is 7. 7 times 2 will get us 14. So the left-hand side, when I plug in the numbers, equals 14. So if the right-hand side equals 14, then I know that it will work, that the distributive property works. You multiply both terms by the number on the outside. So 2 times 3 is 6. 2 times 4 is 8. 6 plus 8 is 14. I get the same value on both sides. The distributive property works. Okay, so you look here. And this is where we have to use the distributive property, because the t, the variable, is inside the parentheses. And especially because it's inside on both sides. If I try to solve this problem by dividing 6 first, because I'm unpacking and times 6 was the last thing I did, then I'll have a 6 on the right-hand side, but I won't be able to get rid of these parentheses, because then I would have to divide by 2. And then I would have to divide by 2 on the left-hand side, and the numbers on the outside of the parentheses would just bounce back and forth, and you'd never get the t outside of the parentheses. So let's distribute. I'm going to distribute this side to do 6 times t, and I do 6 times negative 2. So I have 6t minus 12. When I do the right-hand side, I get 2 times 9. Now remember, I'm not changing the value when I distribute. So since I'm not changing the value of the expression on the left-hand side or the right-hand side, I don't have to do the same thing to both sides. I only have to do the same thing to both sides if I'm changing the value of the expression. All I'm doing now is rewriting the equivalent expression a different way, not a different value. 2 times 9 is 18t. 2 times negative 2 is negative 4. So this becomes 6t minus 12 equals 18t minus 4. Now I want to move the negative 12 to the other side, so I add 12 to both sides. That gives me 6t equals 18t plus 8, because negative 4 plus 12 is 8. Then I want to eliminate the 18t that's on the right-hand side. I want to get no t's on the right-hand side. I just want it to be values, so I subtract 18t from both sides, because this is changing the value. 6t minus 18t is negative 12t. Negative 12t equals 8, so I divide both sides by negative t to get the negative 12, to get the t by itself. And I get t equals negative 8 over 12, which I neglected to simplify, which I want you to simplify. You'll notice that both the 12 and the 8 divide by 4. And so when you simplify this expression, you get t equals negative 2/3. Now hopefully that will help you on the homework. The homework is page 6 in the workbook. Problems 10 to 20 even. It's only 6 problems. And I will see you next class.